Okay, on to evaluating expressions, or substitution, this is called. So it's where we put values into expressions. So in this example here, we've got a is 5 and b is -3. So things to spot: ab means a multiplied by b. So in this particular example, we've got 5 is a multiplied by -3, which is b. And that gives me 5 times -3 is -15. I would encourage you, especially when you're using a calculator, even though it seems a bit unnecessary, put brackets around everything you substitute. It'll just lead to more efficient answers, especially when using a calculator. I'll give you an example here. A minus b, well, in this case, we're going to have 5 minus -3. By putting the brackets there, it's very clear what I'm doing. The calculator will make sure it understands, and you don't miss out any of these negatives. So be careful with this one. When you're subtracting a negative, what I need to do is change it to a plus. So 5 minus -3 is the same as 5 plus 3, which is 8. Another one here, 2 lots of a, that's 2 lots of 5, use those brackets. Subtract 3 lots of, use those brackets, -3. And we just substitute the value of b, replace it with that in brackets. 2 times 5 is 10. -3 times -3, be careful with those negatives, is +9. A negative times a negative is positive, and so the answer is 19. Negatives is probably the thing that trips people up in substitution the most. Moving on then to algebraic expressions. This is all about language, interpreting language and putting it into algebra. So the sum of, that is addition. You could have the total of, you could have add this, various other ones, but the sum of, we are totaling it up, adding together. The difference, this is subtraction, the difference of x and y. Look out for a slightly tricky one, which is if I wrote y less than x, an expression for that would be the same as this, because we begin with x and we subtract y to find, like if you imagine some numbers in here, if I said 4 less than 7, well, 4 less than 7, I'm going back from 7, so I begin with 7, I subtract 4, and it's 3. So just be careful with the language. With subtraction, the order matters. With addition, x plus y is the same as y plus x. Doesn't matter. Right, on to the product. The product means multiply, so that would be x times y. Look out for times, multiply, those sorts of things. Quotient, we don't see that particular language very often, but we do see the expression x divided by y or x over y. If there's anything asking you to share, think division. But quotient of x and y is x divided by y. And again, the order matters here. X divided by y is different from y divided by x. Product, the order doesn't matter. Y times x, x times y is the same. Quotient, the order matters. Okay. So cones, product was times, sum of, add. Just satisfy that. Here's a good example. Cones cost $0.5, balls cost $9. So I'm a football coach buying some equipment. Right, an expression for the total cost of C cones and B balls. Well, the number of cones is going to be multiplied by $0.5. If I had 3 cones, I'd pay 3 lots of 0.5. So let's call it 0.5 times C. The balls is going to be $9 per thing, so it's going to be 9 multiplied by B. And the total added together. So that's an expression for the total cost of C cones and B balls. Linear equations. This is one you just need to practice. Always try and keep everything balanced. We have a left-hand side, then an equals in the middle, and a right-hand side. And whatever I do to the left-hand side, I'm going to do the same to the right-hand side, keeping it balanced. Just before we go on to solve this one properly, let's just interpret this left-hand side. What's happened to the x? I started with an x, I multiplied it by 5, and then I subtracted 8 in that order. I times, like BODMAS, I times first, then I subtracted 8. To go backwards to solve an equation, we kind of need to undo that, do the opposite. So the opposite of minus 8, I'm going to add 8 first. And the opposite of times 5, I'm going to divide by 5. Let's show you how that looks in solving this equation then. So I'm going to, first of all, add 8 to this side and add 8 to this side. Always do the same to both sides. Here I end up with 5x. Over here, 22 add 8 is 30. And then we, last step, divide by, and it's always the coefficient of x. So here, divide by 5, divide by 5, and I get x equals 6. 30 divided by 5 is 6. On to one where we've got unknowns on both sides. So we've got x's, unknowns on both sides. My advice here, it's not essential, but I find it works easiest if you start by cancelling the smallest x. But we're going to call it the smallest unknown, because it doesn't have to be x. It could be a, b, whatever it is. But in this case, it's x. So 3x or 5x, which is smaller, than 3x. So I'm going to start by taking away 3x from both sides. So over here, I'm going to get negative 2, be careful there, the negative stays there, equals 5x minus 3x is 2x. Done nothing with the 20, so I've still got 20. Now my second step is to kind of get rid of the numbers that are with the x's. So I'm going to get rid of that 20 by taking it away from this side, and so I must take it away from this side. Minus 2 minus 20 is minus 22 equals 2x. Divide by 2, because that is the coefficient of x. Divide by 2, divide by 2, and I get negative 11 equals x. There's my solution. So keep everything balanced. Whatever you do to one side, do the same to the other. On to 3f. This is a quadratic equation. The ones above were linear because there were no squares in it. When we bring in these squares, we call it a quadratic equation. Here's a simple example. Something squared is 36. We need to know the opposite of squaring, which is square rooting. So if you get x squared equals 36, simply square root the answer. 36 square rooted what squared makes 36? And that is 6. More complicated one here. Let's think about what's happened here. I took an x, it got squared first. So let's imagine it got squared first. Then it got multiplied by 3, and then it got subtract 1. So to undo this, to go backwards, I'm going to have to add 1, divide by 3, and then square root. So let's do it. Add 1 first. And I get 3x squared still. Done nothing with that. Got rid of the minus 1, and 26 plus 1 is 27. Now I'm going to divide by 3, and I get x squared equals 9. And then I'm going to square root, and I get x equals 3. Okay, so that's quadratic equations, or simple quadratic equations. On to the last one, forming equations. This is basically forming expressions, but you shove an equals in. So I'll just do a quick example. Derek is double my age. Double times 2. The sum of add our ages is 51. So it equals 51. So let's call my age x. So if my age is x, Derek's age is double my age, well that's 2 times x. The sum of our ages, add them together, and we get 51. X plus 2x is 3x. And if I divide by 3, I should find out that x is 17. So my age is 17, which would mean Derek is double my age, 34. Let's just check that 17 plus 34, does it equal 51? Yes, it does. We are correct. There we go. Forming, solving equations.